Ladies and gentlemen, thank you for being here today. I am Nadia from National University Malaysia. I'm here today to present the paper on mobile learning in promoting green building awareness in Palestine. So Palestine is a state which known with its acute political instability and regional tension with Israel, a country where they are facing with a great challenge to almost impossible in managing basic resources such as water and energy for its inhabitants. However, we are not here to talk about the political issues, but to discuss how the learning may help in spreading awareness on green building practices as to be a radical solution for the people there to achieve efficiency with scarcity. Recent research found that smartphones may contribute to the fortunes of underprivileged communities. Researchers believe it is reasonable to utilize these devices and their uses to acquire and provide data and services to help achieve sustainability objectives. Why? Because mobile learning technology enables learners to learn in any context, independent of the time and place. This research used the callous motivation theory in supporting the idea of M-learning. Motivation is often seen as a key to either learning success or learning failure in educational psychology. Motivation to learn is inseparable from efficiency in learning. Greater motivation improves learning outcomes and encourages the learner to strive and learn more. To motivate students, four instructional design principles should be met: attention, relevance, confidence, and satisfaction. The motivational model could provide deliberate instructional criteria to ensure that course design and training material reflects the attributes of learners and meet their needs. The Callis modified IMMS survey used to evaluate whether the mobile application-based instructional materials effectively convey the knowledge, elevate motivation, and inspire people to learn about green building. A survey conducted among 80 students majoring in architecture and engineering at higher technical colleges in Palestine, which divided into two groups, Group A and Group B. Group A was the experimental group, and they were asked to download Let's Get Green apps and spend 30 minutes learning about green buildings using this application. While Group B, the control group, they were given the conventional, which is traditional lecture notes with the same content as the mobile apps and spent 30 minutes with material. These participants are students that not yet to be exposed to the green buildings topic. After completion of the learning activity, students from both groups required to complete a quiz with 20 MCQ questions on green building within 30 minutes, and they were required to complete the survey on the learning experience as well. Since the size of the respondents was large, an internet-based method was used. The survey for this study used 19 questions answered on 5-point Likert scale to measure the motivational reactions of learners. The figures are as shown in the slide. So, with 92.5% of the respondents own a mobile phone device with internet access, while 62.5% access the internet from their phone several times a day. They shown mobile phone and the internet have become an essential item for the local society, and the scalability of this device can bring about a change in spreading knowledge and information on green building practices. A reliability analysis was performed. The Crunchback Alpha presented the questionnaire to reach acceptable reliability, where the experimental group has alpha equal to 0.805, while the control group alpha equal to 0.708. All items appeared to be worthy of retention, resulting in a decrease in the alpha if deleted. For the experimental group, relevant items scored the highest with M equal to 4.2, followed by attention, M equal to 4.075, indicating that the learners believe that the Let's Go Green application capable of stimulating learners' attention and interest concerning green building issues. For all four categories and most items, the average scores in the experimental groups are 4 or greater, significantly higher than those in the control group who underwent conventional lecture notes or material. The result indicated that students were strongly motivated to use this app to learn about green building. The 30-minute quiz used as a learning effective validation tool. The score ranged from 50 to 85, with a median score of 69.75 for Group B and 80.75 for Group A. One sample t-test was run on two groups. It was discovered that the p-value was smaller than 0.0001 and it is significantly smaller than 0.05, indicating that the learning effectiveness for students in the mobile-based learning group was significantly higher than the students in the conventional learning group. Although the study shows M-learning is a valid and potentially successful teaching model, there are issues that need to be addressed, such as continual improvement in mobile learning to reach the optimal potential, considering the content and the graphics for leisure purposes are required. For example, some users have suggested that the app must offer more interactive mechanisms such as a 360-degree 3D panorama of green buildings. While the aim of this paper is not to challenge the effectiveness of traditional teaching methods or other techniques of teaching, this study suggests that M-learning should be seen as an effective teaching aid to enhance the teaching practice, curriculum development, and the educational field as a whole. Therefore, green building concepts should be popularized faster and more convenient in Palestine with mobile learning technology. So thank you for your time in listening to my presentation.